students. In this video, we will be covering the topic circles and we will just know the basic concepts, two theorems. So let us begin with the circles topic. So here you can see there are two circles drawn, and in these two circles there are two lines. One line PQ, this line PQ is intersecting the circle at 2 points AB, and this line PQ is intersecting the circle only at one point, that is A. Now when you see this here, this area, I hope you people know that it's called the segment, and AB is a chord. What is it? AB is a chord and it is dividing the circle into two segments, minor and major. So this is a segment, but this line PQ which is passing through the circle, we call that as a secant. We call that as a secant. Whereas the line which is touching the circle only at one point, we call that as a tangent. This tangent is touching the circle only at one point, and at one point we can only draw one tangent. There is only one tangent at a point of the circle. Okay students, I hope this point is clear, that what is a secant, what is a tangent. We can also say that tangent is a special secant also, where these 2 points A and B, they are coinciding each other and change into one single point A. Okay, now I hope you people know, as I said, that this is a chord AB and which is making a segment, minor segment over here and major segment over here. Same way, you know what exactly is a sector, what is an arc, what is a semicircle. I don't have to repeat it. You people would have done it in your earlier grades. Now let's move to the theorem of this chapter, first theorem of this chapter, which says that the tangent at any point of a circle is perpendicular to the radius to the point of contact. Meaning that if we have a circle given, let's say I have a circle with center O and we have a tangent. Let us draw a tangent which is touching the circle at one point. Let's say that point is P. Okay, and the tangent we name it as AB. That's a circle. Now what is given whenever we have theorem, I hope you know that you draw the figure based on the theorem statement and then write given. So what is given to you? You are given that there is a circle with center O. AB is the tangent which is touching the circle at P. This is touching the circle at point P. Now what do we have to prove? Let us read it once again. It is saying that a tangent at any point of a circle is perpendicular to the radius. So what is the radius? So this OP is the radius. So now we have to prove that OP is perpendicular to AB. This is the thing that we need to prove. So how do we prove it? You cannot do anything congruence or anything over here. So what we do over here is, let's take a point outside the circle on this line AB. Let us say I take a point OQ. So to do the proof, take a point Q on AB. Now as this Q is outside the circle, we know as Q is outside the circle, so I can say that this OQ is greater than OP. Can I say? Because if I join it and join, let me write that you have to join also. Take a point Q on AB and you have to join it also. Now you all can see that this OQ, as it is outside, so, and OP is the radius, this is the radius, so obviously this OQ is outside, so this distance is more, right? So this distance is more over here. Now, as this distance is more, if I consider many other points over here also, let me take one point here, let me take one point here, and you join, all these distances you see will be greater than this OP, right? Correct or no? As Q is outside the circle, so, and P is on the circle, so you got that OQ is greater than OP. So you can say this is true for every point on line AB except P. This thing will be true. Let's say if you take any point M, then this statement is true for all those other points except this P. So we can say that what? Any idea what we can say from here, students? What do you have from here? We can say that the shortest distance, OP, is the shortest distance then. It's the shortest distance. So therefore, OP is perpendicular to AB, because these all will become hypotenuse, right? So it's OQ, ON, OM, all these are hypotenuse, and OP is the shortest distance. So we can say that OP is perpendicular to AB. I hope that part is clear, students. Fine. So we are done with the theorem which says that tangent at any point of a circle is perpendicular to radius. This is a very important theorem that we'll be using in solving the questions. How to prove it? You need to take a point which is exterior to the circle on this line AB and say that OQ is greater than OP, because if you take any other point also, that will be greater. The reason for that is that OP is the radius and Q is outside, so it is greater. You can say that it will be there for all other points also if you take on AB. Hence, OP is the shortest distance and shortest distance is perpendicular. I hope it's clear, students. Now, let's do few questions from your NCERT book only. So, let's begin with the first question. How many tangents can a circle have? If I talk about how many tangents can a circle have? A circle can have infinitely many tangents, because on a circle you can draw a tangent here, you can draw a tangent here. At any point there are infinitely many points, so you can draw as many tangents as possible. Fill in the blanks now. A tangent to a circle intersects it in how many points? A tangent is intersecting always in one point only. A line intersecting a circle in 2 points is called a secant, that we have drawn. That if you have a circle, the line that intersects circle at 2 points, these 2 points is called a secant. A circle can have dash parallel tangents at most. So draw one parallel, to uska parallel mein opposite diameter it will go and there will be only one pair. Pair means 2 parallel tangents at most. Okay, so I can say either one pair or 2 parallel tangents. The common point of a tangent to a circle. The common point of a tangent to a circle and the circle. There is a tangent to a circle. This is a tangent to a circle. Okay. And the circle. What is a common point that's called as? That's called as the point of contact, where the tangent is touching the circle. Okay, students. Now this is done. Now let's move to the next question. A tangent PQ at a point P of a circle of radius 5 centimeter. So let's draw a circle. Tangent PQ at a point P, tangent PQ. So here we have tangent PQ. Radius of the circle is given as 5. Meets a line through the center O at a point Q. It's meeting at Q, so that OQ is 12 centimeter. Find the length of PQ. So you need to find the length of this PQ. Have I drawn the figure correct, students? The tangent PQ at a point P of a circle of radius 5 centimeter meets a line through the center O at a point Q, so that OQ is 12 and this is 5. So we need to find out PQ. So there is a mistake in this question. It's square root 119. Now, how do we solve it? We know that it's a right angle triangle, OPQ. So here hypotenuse is this. Let's take this as perpendicular, this as base. So we know that base square is hypotenuse square minus perpendicular square, which is 12 square minus 5 square. So what will it be? 144 minus 25. So that becomes 119 and it is base square. So when you remove the base, it will be square root of this. So that's the answer. Square root of 119 centimeter. I hope that's clear, students. Okay. Now let us move to the next theorem of the chapter, which is very important one. The theorem says that the length of the tangents drawn from an external point to a circle are equal. So first let's draw the circle only. This is the center. Let's take a point P over here. Now the length of tangents drawn from the external point. P is an external point. From here I have to draw tangent. So let me take one tangent like this. One here. So let's say it is touching PA and PB are the 2 points. Okay. So what will I write given as? Given PA and PB are the tangents drawn from external point P. What do you have to prove? You have to prove that PA equals to PB. So whenever we draw from one point any two tangents, so these two tangents are equal, that is what you have to prove over here. So how do you prove? First point, what you do is you just join OA, join OB and join OP, right? So join OA, OB, OP. Now here students, we will be using the first theorem that we have used, that tangent is perpendicular to the radius at point of contact. Yeah, you see there are two triangles and in these two triangles you have to prove the sides equal, so you will be doing the congruency part over here. Okay students, so let's take the two triangles, triangle POA and triangle POB. Can I say PO equals to PO common, right? That's a common, I can say hypotenuse I'll use here. Okay. Now what else I have? I have OA equals to OB. They both are the radii of the circle, so they both are equal because this is radius, that's a common side, right? It's a common side, radius. Now what is left? So angle OAP equals to angle OBP. This angle is equals to this angle, both are 90 degree. Reason for that is, you'll write the reason, that tangent is perpendicular to radius at the point of contact. So by which congruency rule I can say that triangles are congruent? By RHS, triangle POA is congruent to triangle POB. So both the triangles are congruent, and from here I can say that PA equals to PB by CPCT, hence proved. So student, this theorem is important and its proof is also important. It generally comes in exam either for 2 marks or you'll use it to solve a lot of questions. Okay, so I'll just repeat it once more. In short, that you need to prove that there are two tangents drawn from one external point P, that is PA and PB. You need to prove that this PA equals to PB. So how do we prove it? We join OA, OB, OP and we take the two triangles POA and POB and prove them congruent using RHS, and then by CPCT we will get that PA equals to PB. Now from the same theorem students, or from the same diagram, if you see, or if I draw it somewhere else, in these questions also you can see, or let me just take a smaller one and draw it over here. I have a short space, but I hope you can. This is the point, let's say, and I draw one more over here touching it, PA, PB, and you join it like that. As the two triangles congruent, this is 90, you people can see that these two angles are 90 degrees. So what about these two angles? This OAPB is a quadrilateral. These two add up to 90 and sum of all four is 360. So from there you can say that these two are supplementary, right? Angle O and angle P, both of them add up to 180 degrees. Fine. So we will be using it to calculate our further questions. Okay. So now let's move to the further part of this video and see what all questions are over here. Now move to question number 1. This is from next exercise of your NCERT book only. Now what does it say? That from, let me just take a little space over here. mark it as question number 2. Yeah. Now, from a point Q, the length of tangent to a circle is 24 centimeter and the distance of Q from the center is 25 centimeter. The radius of the circle is, okay, so let's draw this. This is based on the first theorem that radius is perpendicular to tangent or tangent is perpendicular to radius. So there is a point Q and a tangent is being drawn from that point Q. So let me take that point Q over here and you have drawn a tangent. Okay, let's meeting it over here at P, and the distance of Q from the center let's say is O, and this distance of Q from the center is also given to you as 25 centimeter. Length of the tangent is also given to you as 24 centimeter. You have to find the radius. I hope the diagram is clear, the figure is clear, students. Yeah, again it's a right angle triangle, triangle POQ mein what do you have? Hypotenuse is OQ. Please take care that opposite to 90 degrees is always the hypotenuse. So you know hypotenuse square is perpendicular square plus base square using Pythagoras theorem. So hypotenuse is OQ. You have to find out OP, so which is the perpendicular will take. So perpendicular square will be hypotenuse square minus base square. Hypotenuse we are taking as 25 square given and 24 square. So what will you get over here, students? So 25 is 625 square. 25 square is 625. 24 is 576. So you minus it. What will you get it as? So 15 minus 6 is 9 and 11 minus 7 that is 4. So that is P square. So P will be square root of 49 which is 7 centimeter. So that is your answer, students. I hope it's clear. Now let's move to the next question. In this figure, if TP and TQ are the two tangents, you know they are equal, and I think I told you people for this question what we have to do. So I hope you remember. So here there is a circle with center O and angle POQ is given to you 110. As I told, you know that OPTQ is a quadrilateral, right? So you know P plus Q is 180 because both are 90, right? 90 plus 90, correct? So I know that angle O plus angle T also is 180, 360 minus 180, quadrilateral angle sum. So angle O is 110, so what will be T? 180 minus 110 which is 70 degree. I hope this is also clear, students. Now let's move to the next question. Now this next question, what is this next question saying? That we have to calculate if tangents PA, PB from a point P to a circle with center O are inclined to each other at an angle of 80 degree. So again you have a circle, you have two tangents drawn from this external point P. Okay, PA and PB over here, and center is again O. Join this 90 degree, 90 degree. Now they are inclined to each other. Basically the angle between them is given to you as 180 degree. You need to calculate this POA. Okay, this angle is 80 degree, the whole. Okay, so angle APB is given to you as 80 degree. Now students, as you know that in the second theorem what we have done is we proved that these two triangles are congruent. If these two triangles are congruent, we have PA equals to PB. ये तो by default equal है because radius. And then this angle also is equals to this angle. Yeah. So basically this line is a bisector of these angles. So if this whole is 80, you can calculate first what is AOB. AOB you can do by 180 minus 80. So that becomes 100 degree. Angle AOB is 80. So half of angle AOB is what? Angle POA. So angle POA equals to half of angle AOB, which is 50 degrees. I hope that is also clear, students. Yeah, because the same theorem, if I go back to that same theorem, with this same theorem, as the two triangles are congruent, so by CPCT you have this also equals to this also equals to this. Yeah, so you can do that part also. I hope this is clear. Now Next question. All these questions are not in that sequence but I have taken from NCERT because they are related to the theorems that we did in this video only. Now the length of a tangent from a point A at a distance. Length of a tangent from a point A at a distance 5 from center. Okay, now what is it given? That there is a point A. This point A is how far from the center? 5 centimeter from the center. And the tangent that we have taken is 4 centimeter. You need to find the radius again. Okay, students, I hope this figure is clear. Read it carefully, the statement. So you just have to find out R. So you can again say that this OB square is equals to OA square minus AB square. Again, this perpendicular square is hypotenuse square minus base square. So 5 square minus 4 square. 25 minus 16 is 9. So that's OB square, but OB, which is your radius, is square root of 9, which is 3 centimeter. Okay, students, I hope it is done. Now, the 10th question is same as the question related to the second theorem only. Basically, you are proving that thing only. Now, prove that the angle between the two tangents drawn from an external point to a circle is supplementary to the angle subtended by the line segment joining the points of contact of the center. Okay, so now let me first draw the figure and make it very clear. This thing, you have this circle, there is center, take a point P outside and draw two tangents. Okay, this is not coming over there. Let me draw it a little better. Yeah, now better. Okay, so we have PA, PB. Now, prove that the angle between the two tangents, so we are talking about this angle, angle A, P and B from an external point P to a circle is supplementary to the angle subtended by the line segment joining. So, line segment that join this point of contact, right? A and B, yeah? And this is subtending an angle at the center. Yeah, at the center. This AB is making angle AOB at the center. So let me just write what is given to us. Given is that PA and PB are the tangents drawn from external point P, right? Now AB is the line joining point of contact. The line segment joining the points of contacts. Okay, and this is making an angle AOB at the center. Now we need to prove is, what do you have to prove? You have to prove that angle APB plus angle AOB is 180 degree. Supplementary means the sum of two angles is 180 degree. That is what you have to prove. So it's supplementary to the angle subtended by the line segment joining the point of contact at the center. So how do we do it? It's a very simple proof. We know that OAPB is a quadrilateral. Okay. In a quadrilateral, angle OAP plus angle APB plus angle OBP plus angle AOB, that is what, 360 degree. Angle sum property of a quadrilateral, right students? So OAP we know is 90 degree. This I do not know. This is also 90 degree. AOB, that is 360 degree. Now why that is 90 degree? You know that radius is perpendicular to tangent or tangent is perpendicular to radius. So APB plus AOB is 360 minus 180. 90 plus 90 is 180. So it comes out to be 180. So we proved that, yeah. So that the sum of this and this angle is 180 degree. So we are done with this question also, students. We proved it. So I hope Whatever we have done is clear to you in the video. Please revise the concept thoroughly, solve all the questions. And in the next video, we'll be solving other questions of the same chapter.